All right, as you're figuring out what each of these equal, for some of them you can just look at them and know. Hopefully the more you practice math, the more of them you can just look at them and know. For instance, 3 plus 8. Hopefully you know that one off the top of your head and you don't need to rely on a visualization. However, for some of these, a visualization could be very beneficial. It's going to help us to see our way through. A number line is a great way to do it. So for instance, just kind of visualizing, actually I'm going to assume here at the start that we actually do know the 3 plus 8 off the top of our head being 11. The 3 minus 8, a way to visualize what's going on there is imagine you start at 3, and then if we subtract 8, that means you're going to go left 8 units. And so you can actually use that number line to visualize where that's happening. So if you're getting stuck on any of these with the subtraction or the negatives, visualize that. All right, so for the 3 minus 8 then, if I start at 3 and then go down by 8, that ends up dropping me off at negative 5. 3 plus a negative 8, so that means I'm starting at a positive 3. But if I'm going to add negative 8, that means I'm actually going down 8. So actually this one is exactly the same as the last one. It also gives us negative 5. And 3 minus negative 8, I start at 3, and then minus normally means left, but negative means flip it to go the other direction. So we're actually going to be going to the right 8 units here. And so that's why it ends up dropping us off at 11. All right, now for the second row here, negative 3 plus 8. It's the same idea except that I'm starting at negative 3 instead of starting at positive 3. And if I'm going to add 8, I'm adding positive, so that means I'm going to the right 8 units. And so that ends up dropping me off at 5. Negative 3 minus 8, so I'm starting at negative 3 again. Minus 8 means go down 8 units. And so that one ends up dropping me off at negative 11. Negative 3 plus negative 8. So plus normally means go to the right, but the negative means flip that around the other direction. So this one's going down by 8. And so that one is also negative 11. And then negative 3 minus negative 8. This is one where you got to deal with all of the negatives all at once. So I start at negative 3 on the number line. That takes care of the negative in front of the 3 right there. Then minus a negative 8. Minus normally means left, but the negative means flip it the other direction. So we're actually going to be going to the right 8 units. And so I count over to the right from the negative 3, and notice that ends up dropping us off at 5. And so then you can also see the little rule that we can remember. Anytime you see that minus and negative, when they're right next to each other like that, it becomes the exact same thing as plus a positive. So next up, we're going to be looking at solving equations that involve a negative in them. And so we're going to solve these two equations together. So go ahead and write down the first one, the negative x plus 5 equals negative 7. All right, and so our goal with solving an equation is, as it always has been, to get the x by itself. Now there's two things in the way of the x being by itself here. The negative that's out front of the x and the plus 5. And so I got to get rid of both of those. I'm going to start by getting rid of the plus 5 here. In order to do that, I subtract 5 from both sides because I'm undoing the addition, and the opposite of addition is subtraction. And then that leaves me with negative x equals negative 12. Now, what do we do about that negative? Well, when you see negative x, really what it's saying is that is just a way of saying negative 1 times x. That's the exact same thing. So if I want to get the x by itself, I'm going to be undoing this multiplication by negative 1. And so if I'm going to undo multiplying by negative 1, I'm going to divide by negative 1. So I divide both sides by negative 1. We end up, in this case, finding that x equals 12. All right, now on to the second equation. Again, I want to look and see what do I need to get rid of in order to leave the x by itself. You notice there's actually quite a bit over there. Now I'm going to actually start by getting rid of the addition and subtraction that's on the outside here. That's going to be the plus 15. The reason I start there is because when I'm solving an equation, basically I'm undoing through the normal order of operations. So I actually start at the bottom of the order of operations. In other words, start at the bottom of PEMDAS. All right, so if I'm going to start by getting rid of the plus 15, that means I subtract 15 from both sides. So I now have negative 7 equals the negative absolute value of x plus 2. Now what about that negative? Well, first of all, I want you to note that the negative is outside of the absolute value. If you're looking at this and thinking, wait, absolute value makes it positive, that's true for whatever's on the inside. But since the negative is on the outside, the absolute value will not have an effect on it. So we end up approaching this one kind of like we did the last problem. That negative absolute value is like -1 times the absolute value. And so in order to get rid of the negative, I'm going to divide both sides by -1. And then that gives us 7 equals the absolute value of x plus 2, which is a good thing that the absolute value equals a positive, because remember, absolute value always equals a positive. If it equaled a negative, we'd have some big trouble going on. All right, so now I need to solve this equation. Thankfully, now it's simple, at least compared to what it was at the start. It's something we've practiced before. How do we get rid of the absolute value symbols? This is the one where we split it into the two equations. Because if the inside of that absolute value equals 7, the absolute value will be 7. But if the inside of that absolute value equals a -7, it'll still equal 7, because the absolute value makes it positive. And so we split it up into the two equations, solve each of those two. All right, and so in order to finish solving this one out, then we subtract 2 from both sides in both of those equations because they're both x plus 2. And so we end up finding that x equals 5 and -9. And lastly, today we're going to be solving these two equations. So write down the first of those two. All right, and so in order to solve that first one, once again, I want to get rid of any addition or subtraction on the outside first. Now, when I talk about getting rid of the addition and subtraction, that means the 19 here. So I'm going to be subtracting 19 from both sides. Now, notice I'm not dealing with this -5 yet. That's because it's trapped inside the parentheses. Therefore, it's actually the P in the PEMDAS. It's actually at the top of the order, so it's actually the last thing we deal with rather than the first. All right, now I have -16 equals a negative x minus 5 squared. I now need to get rid of the negative, because if I think back to my order of operations, PEMDAS, I just got rid of any addition or subtraction. The next thing I get rid of is any multiplication or division. And remember that the negative is like -1 multiplied. So it actually goes in as multiplication. The exponent is what I'll deal with after that, because undoing an equation means you're going backwards through order of operations. All right, so in order to get rid of the negative there, I'm going to divide both sides by -1 once again. Anytime you want to get rid of the negative, divide both sides by the -1. And thankfully this one worked out to our benefit because, again, it should be equal to a positive when we square something. So I now need to get rid of the squared. I need to get rid of the exponent. What do I do to both sides to undo a square? Yep, we square root both sides. Now when you square root both sides, this is the tricky part. Remember that plus or minus. Because when we take the square root of 16, it gives us both 4 and -4. 4 squared equals 16, but -4 squared also equals 16. That's why we got to account for both of those. And so then, solve both of those two equations to finish it out. And so in this case, we end up adding 5 to both sides. You should be finding that x equals 9 and 1. And so you'll notice here, again, like on this left one over here, we got the -4 plus 5. Being able to do that addition and subtraction with negatives mentally in your head without having to rely on the calculator, again, comes into play. All right, once you have that one written down, then go ahead and write down that second equation on this page, and then we're going to solve that one through together as well. And just like all the previous problems, I want to get rid of any addition or subtraction first. The plus 12 is trapped inside the square root, so I can't do anything with that, but the plus 5, I can do something with that. So I subtract 5 from both sides, which gives me the negative square root of x plus 12 equals -4. Right, now I need to get rid of the negative, because again, before I can get rid of the square root, I have to just have a square root there. So what do we do to get rid of the negative? We should have that down now, right? We divide both sides by the negative 1. And so I now have the square root of x plus 12 equals 4. Now I can get rid of the square root. What undoes a square root? Squaring it, yeah. And so I square both sides. Now notice when we square both sides, I don't need to worry about the plus or minus. That's when I take the square root of both sides. When I square both sides, I simply square both sides. By squaring the square root gets canceled out. I'm left just with what was inside, which in this case is the x plus 12. On the right side, I square the 4. 4 squared is 16. Again, you can do all this stuff without a calculator, because for instance, 4 squared, that's just 4 times 4. All right, and now we got x plus 12 equals 16, so we just have one last step to figure out what x is. That's get rid of the 12. So, subtract 12 from both sides, you should find that x equals 4.